Okay, so in our previous class, we stopped at this slide, distance from the main sequence. And I would start with this slide again. So what is abstractness? Abstractness, if you go back in this slide, it is simply a ratio of all the abstract elements you have in your code, and then you divide it by all the concrete artifacts you have. Like the simplest way to find out how many concrete artifacts you have in your code element is to just count the lines of code, for instance. Okay, so this is what this summation signs tells it here, that you need to count simply all the abstract elements, put it above, and then you count all the lines of code and put it over here, divide it, and you will end up with how to say, you will end up with this abstractness. Let me see. Everything fine. Are we recording? Yes. Okay. And now, if you want to compute instability, all you need to do is you put above all the afferent coupling, all the outgoing connections, just count them from your code base. And underneath, you divide it with afferent coupling, all the outgoing connections, and plus all the incoming connections. And once you do that, you get instability and you get abstractness. Once you have these two things, all you need to do is you got two values now. So here you have 0 over here, and this is 1. This is 0 and this is 1. Same here. So you have one value on instability and you have one value on abstractness. So based on that, since you have 2 points now, abstractness and instability, you may end up here, you may end up here, you may end up here, 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 maybe on this line, like that. And then if you want to know how good or bad your code is according to the distance from the main sequence, all you need to do is compute this distance. And how you compute this distance? With this formula. Add instability, abstractness and instability, subtract it with 1, and just take the positive value. So this is the absolute value. So just if it is a negative value, make it plus. It won't be a negative value, by the way. So you end up with this distance due to, with this measure, like this one. And as we discussed in our previous class, if you end up somewhere here, your code base is really healthy. However, if you end up in this area, for instance, that means it is zone of, we can call it zone of uselessness, because really your code is too abstract, having little implementation. And if you end up somewhere here, and that is, we can call zone of pain, because if you change something in your code, then you will spend hours and hours just to fix that, because your code doesn't have enough abstraction. It is just concrete elements. So this is how we define distance from the main sequence. Okay. So another really important measure that we usually use on object-oriented programming is called connaissance. And if we just look at the definition of connaissance as defined by Marco Consolaro, it is that the birth and growth of two or more things at the same time. So relation between two things, how when they change, how the relation stays the same. So that is just a general definition. But if we look at its proper definition, so it is a generalization of coupling and cohesion. We learned these two measures before. So connaissance, what it does, it generalizes coupling and cohesion into one holistic approach. So this is one holistic approach, and it is defined by the author in 1996 in this book. So let's see. So what we do in connaissance is that we recast afferent and efferent coupling metrics for object-oriented languages. And then, so what it says is that two components are connaissant if a change in one would require the other to be modified in order to maintain the overall correctness of the system. So you got two components, okay, and they are depending on each other. So we will say that they have two components are connaissant if you make a change in one, then in order for your code to work, you have to reflect those changes to the second component also. So that would be connaissance. So it indicates the problem of change. So we can say that the quality attribute modifiability is being affected by it. And we have two kind of connaissance, static connaissance and dynamic connaissance. So we will see those in a minute. So architects, as an architect, when you will work as an architect, you will view it as a degree to which something is coupled. So you have connaissance between two modules, two components. They are connected to each other. They are coupled with each other, and you can have this one is like a source code level coupling, source code level dependency on each other. So so this is how we define them. We got static connaissance, connaissance of name, type, meaning, algorithm, position. And then we have dynamic connaissance, connaissance of execution, timing, value, identity. So dynamic connaissance, as the name suggests, is discoverable at runtime. And static connaissance, as the name suggests, it is discoverable at compile time. The more you go in the upward direction, the better connaissance you have, easier to manage. And if you go somewhere here in the dynamic part, it will happen on runtime and you will have no control over it. Okay, so if you have, so we will see what these are. But what we really try to do here is when we are working on the coupling of our components, we try to stay in this area in the static connaissance so that in, in the on the compile time when we are checking our code, we can see the dependencies between components and fix when something is modified. We can control the ripple effect. We can go to all the modules and update the things that need to be changed. Okay. So connaissance help prevent code smell. So I discussed also the concept of code smell previously. The code smell is something like your code start to rot. Means like when the food becomes bad, it start to smell. So it is the same with code. You started with a nice design, but in the middle of your project, what happens? Some of the requirements change, some of the team members are replaced by other team members, some delays happen, and your code starts to become unmanageable. It starts to grow in all directions, and we call that code smell. That we can say that your code is now rotting just like bad food. Your code is now not working properly and it is giving you smell. So properly, if we define it, it is a deeper design problem, making the code harder to understand, maintain, or extend, even if uh, it currently functions correctly. Though it functions correctly, but you are so much, frightened to change something because you fear that if I change something here, it might break the code, and I may have to spend hours and hours to fix all the ripple effect of that change. So that would we would call that code base that it is now it has some smell. It has rotten just like bad food. So this is the idea. So the first dependency or static connaissance is called connaissance of name. Connaissance of name. It is a tight named coupling. And I would try to give an example. We have a class like time. Of course, we have, hour, minute, and seconds. This is our constructor. We take local variables and we pass these values to our attributes here, as you can see here. So if I go here and change something here, you know that I need to make a change here, and I need to make a change here, just, to make it consistent. So with that, we can see that these are our dependencies within the code. If we make a change, then uh, this is these are the dependencies as shown in this slide now. So our is this is this one. So you have to just remember that. So what we say that multiple components must agree on the name of an entity. So you have to agree any class that later on will use your time class should know that the attributes you have for hour, minute, and second, how they are spelled, for instance. So the connaissance of name is about the names of your attributes. Sorry for that. The name for your methods and so on. So I will try to give you one more example, very much similar. Like for instance, some people try to, write these attributes like this. I prefer, among others, prefer to write it like this. So here is you have got hour, minute, and second. Here also you got the same similar name, hour, minute, and second. But through this, you remember that this hour actually is this one, this minute is actually this one, and so on. So this is what connaissance of name looks like. So we have to agree on the names of your attributes and your methods so that other classes that depend on time class, they can use it the way you define it here. And if you try to change something here, now you have to go there and change there as well. Then comes connaissance of type. And it is all about multiple components must agree on the type of an entity. So I will try to motivate it with one example. So here we have this example like if your hour has a type int, then in your constructor it has to hour should have a type int. Same goes for minute and same goes for second. So that is connaissance of type. So now let's say if there is another class using this time class that you define in one module, they must know the types you define for your attributes here. So we must agree among these components what type your hour will have, what type minute will have, and what type second will have. Okay, and you may ask yourself, and actually here I want to ask you guys, what do you think? Can we have any other possibility here instead of int? Anyone who wants to contribute here? So do you think that we can have anything else over here instead of these ints?
I think we can use double.
Great, we can use double. Yes, we can use float. But anything else comes to your mind other than that? Anyone else? Okay, I would say that we can go beyond that, and we can also have like enum to be sure, because int allows us to have all kind of values in this hour, and we need to validate if we got a proper hour, right? Hour can be from 1 to 24. That's not too many values to really cover if we have an enum. Let's say this is 1, this is 2, and so on. So we can do that also. You can have enum, you can define another class for hour, you can define another class for minute, just to control this validation so that the values in these hours are and minute and second are what we expect. If we thought about minute, minute can be 1 to 60. Yeah, it's a little bit more, but still not too much. Second, same thing, it is 1 to 60, not too much. So it can be nm also, just a food of thought. So let's continue. So this is the connaissance of type. We have to agree on the type that your time class will use, so that if you make a change here now, and all the classes that use that time class must, you know, update themselves. So we must agree in the beginning the type of an entity, what that will be, so that our code can really work. And then comes connaissance of meaning. What is connaissance of meaning? Like, for instance, multiple components must agree on the meaning of a particular value. Like, for instance, let's say you define Monday to be 0 and you define Tuesday to be 1. And if you do that, now all the other components who will use your API or this component yet that you define now must agree on that 0 means Monday and 1 means Tuesday, right? And if we don't agree on that, our code will not give us any error. There is not a syntax error, but we will have some logical errors. Instead of Monday, we may have, some more, some other values that will break our code logically. So what could be, like, it might be good idea either, if we have this int Monday equal to 0, Tuesday equal to 1, you document that so that all the people later on using your module or your class about time agree on what Monday is 0, what Tuesday is 1. Or you may end up or defining an nm for day, weekday, for instance, and there you define them like this. So whatever we do, we have to agree on the connaissance of meaning. What conventions are we going to use? If we use this one, then you have to look up the API, check what Monday means, what Tuesday means. And if you do it like this, it would be a bit more straightforward. And then comes connaissance of algorithm. Like, what it means is that if you have multiple components, one component depends on another one, and they are using some kind of encryption, they communication happens through network. Before sending it to the network, you encrypt your data, send it, and then on the other side the client decrypt that. Or imagine you have some values to write in your database, but you don't write raw values. You encrypt them and then you write that into database. So in that case, there are two things. So for instance, in the example, like this is some kind of server, you receive values from server. What server does, it encrypts your data, send back to you. And now in client side, you have to decrypt the data in order to display it properly, right? So the connaissance of algorithm is that we must agree on the algorithm, encryption algorithm, just for the example, on both sides of uh, the communication, so that we can write in a right way, we can decipher, decrypt our data. So multiple components must agree on particular algorithm, like hashing algorithm. This is an example. For instance, imagine, and it can happen a lot, like on the server side, just a new update appeared in operating system or in your software, and it is now SHA-3, and you did not update your software. Maybe because, time constraint, maybe some other reasons, you decided not to update. And now you are having SHA-2 algorithm, here you have SHA-3 algorithm, and it's not going to work anymore. So the the connaissance of algorithm says that if two components depend on each other, then, and if there is some algorithm that both depend on, they must agree on that particular algorithm, what that algorithm would be. And only in case if you update something here, then you have to update on all the other components that depend on it. So that would be static connaissance of algorithm. Then we have connaissance of position. Like, I will try to give example through this. function. So multiple components must agree on order of value. So like in update seat, let's say you got this method update seat for a flight reservation system or something. You have, a string name and then string seat location. And what you do when you were adding values, you flip them. Instead of name, you put seat location, and instead of seat location, you put name. So no problem. There is no compile error. As you can see, both are string types, right? But now there is a bug in your code. So again, the connaissance of position says if two components or more than two components depend on each other, they must agree from the beginning the position, the connaissance of position, what would be the first thing and what would be the second thing. And all the components that use it must follow that convention. So another example, like we got this notifactor. So it's an email send application. We have this method called send email. What it requires from you is to provide recipient, sender, and message. And then through this, you do other things also here, like you create an email, then you fix that recipient, then through this method email from, you fix sender, you write the message fix to the body method, and then you send that email. However, when you were using this notificator dot send email, when you use this method, what you did right now, it all of these are just strings. So it's easy to make mistake. Instead of sender or recipient, I can put sender here. I could put, instead of message, I can put maybe receiver's email. So again, connaissance of position says you must agree on what is the position in which we expect values if two components depend on each other. So if I update something here, it has to be updated in all those uh, other piece of code that depends on this notificator. Okay. So this is one way we can make mistakes. As you can see, string, 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 and in string, I can write anything. So how can we fix that? Any idea? Anyone wants to contribute here? What could be an easy way to fix it? One thing we can do is we can have types for recipient, a type for sender, a type for message. Instead of making them generic string, 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 we can make them specific, records or classes. And through that, we know that recipient is different from sender and sender is different from message. So let's see what we have here. Yeah. So what we did here, exactly the same. We created a new class recipient, a new class sender, a new class message. Now we can't make this mistake. So recipient, if I try to put sender here, this code will not work. So on compile time, it will enforce me to follow to give a recipient here and sender here and message here. And with this fix, now we have done two things. We have had connaissance of name and connaissance of type in the code. Okay. So, and also the connaissance of position through name and type. By fixing the type, by fixing the names, we also get connaissance of position by defining this recipient, sender, and message class. I hope it is clear. So now if I make a change here, of course, I need all the code will not compile. All the remaining parts of the code will not compile until I make these changes in that piece of code also. So the connaissance of position says multiple components must agree on the order of value. And now what we have studied so far all is kind of summarized in this slide. We learned about connaissance of name, connaissance of type, connaissance of meaning, the convention, connaissance of algorithm, and connaissance of position. And now that was the static connaissance. And now we will talk about dynamic connaissance. And we always try to bring up, because if it is dynamic connaissance, we will not be able to see those effects in compile time, because our code will compile nicely. But it is only the runtime when the problem starts to appear and our application can crash, because I made some change in the execution in one place, and in the other places in my code who was depending on that part was not updated. I did not get that message because there was no compile time errors. So we just went through with the code, and now we can have our code can break on runtime. And it could take hours to maintain that code. Maintainability would be affected. Okay, let's see. So dynamic connaissance analyzes at runtime calls, and it is about identifying dynamic connaissance. So identifying dynamic connaissance is more challenging, as I just said, because it happens on runtime. Whatever is happening on compile time, you can see that you can have static call graph. Your code will not compile if you intelligently code the way we did. For instance, one example here, if you try to depend on specific classes like that, now your code will not compile, and you will go and update all the affected parts of your code. But on runtime, no, you don't have that available now. So the first example we want to see is connaissance of execution. What it says is that the order of execution of multiple components is important, and we must agree on that. So here is a very simple example. Imagine we are using this API that allows us to send emails. Okay, so we are depending, our code is depending on that email component. So we create a new email like that, then we set recipient, then we set sender, and then we just send that email. And then afterwards we set the subject. Of course, we would never reach that. So this is lost. Why? Because the order in which you execute these commands were really important. You should have run it in the line number 4, and then you should have written this line at line number, this command at line number 5. So this is what called connaissance of execution. You will not receive any error if you make such a mistake, right? But you did not get what you wanted to achieve with if you mess up with execution order. So as we know, it won't work correctly because certain properties must be set in order. So how can we fix that in the code base so that it is manageable? So I will give you one possibility here, and that would be using a builder pattern. So a builder pattern can work something like this. So you set up a builder. So like there is a builder B. Instead of email, you depend on a builder B. And what builder B does, it asks you to set up things in advance. Until everything is set up, you can't send an email. So in order to send an email, you need to set up a builder. Builder is just a class. Let's say builder B equal to new builder. And now you need to set up a recipient. Then you need to set up a sender. And if you just do that, don't do this, and try to send email like that, email.send with the builder B, you can't, because you did not set up your subject. So that could be one way of enforcing the connaissance of execution within your code. So you have to set recipient, you have to set sender, you have to set subject. Now builder is complete. And now you can execute this line, email.send, what send? Whatever you have in this builder B, send that. So email is going to this recipient by this person with this subject and other details. So you can use, connaissance of execution is all about agreeing on the execution so that something is correctly done and you can enforce with many ways, and one of them could be this builder pattern. And then comes connaissance of time. A lot of things happen in real life in our computers in parallel using multiple threads. So the timing of execution of multiple components is important. So one example could be, when multiple threads access the same shared resource simultaneously, it can lead to unpredictable outcomes. Like for instance, imagine multiple threads accessing your database and updating and deleting or working on your records. So you have to really enforce connaissance of timing, that the timing of execution is already predefined. What will happen first, who will do second, what will be done second, and so on. So one example could be this one. I'm not giving you any example for this one right now, but there are many ways, especially in asynchronous communication, to control the connaissance of time. But I found it to be a bit more complicated for our topic, so I am just skipping that. And then we have connaissance of values. So it happens when several values relate to one another must change together. So there is some shared resource. Okay, maybe you have three databases. Whatever value you change in one database, so one is the main database and other ones are just shadows. So that if the main database have some problem, it can't, you can't really connect with it, then the second database will take over so that there is no delay in our system. So in that case, whatever changes happen in database one must happen in database two also. In that kind of situation, connaissance of values is really important. So this is one example. And one example is given here is that like a rectangle defined by 4 points. So let's say that is your rectangle over here. And now you try to resize it. So when you try to take it from here and try to resize, increase or decrease, all these values must increase or decrease in some certain ratio. So they must agree or they must decrease or increase in proper ratios that you have defined in your code. So that would be one example, another example of connaissance of values. Another example would be transaction and distributed system. As I just said, you got multiple separate databases. When you make a change in one database, you want to make that change to another database also. So you need to update a single value across all databases. So the values must change in all or in none. So if you got one main database and two shadow databases, either we able to change values in all of them, and let's say we update here, but we were not able to update that value here due to some reason, we must roll back. Then it will not be updated in any one of them. So that would be the connaissance of value. Of course, really hard because now it is dynamic. There is no source code level. It's not source code level. It is now dynamic. I will also try to give one more example. The similar kind of example we followed in our previous slides. So the time class. How connaissance of value, can in small databases. That's very simple example. I mean, in small example, how can we see it? So you got your time class, and you decided to have them int or double. Everything good. And now there is another module using your time class. So my time equal to new time. And here you put the values to be 27, and which is all okay. The first thing is 24. I mean hour. Can't be 27. Second value you fixed 76. Well, it can't be 76. Third value you fixed 82. Well, it shouldn't be 82, right? So we need to have some mechanism. So this is the connaissance of values. The connaissance of values says that we should not be able to do that. How can you ensure that you should not be able to do that in other components? We agreed when we said it is hour, minute, and second, some way we agreed these values to be between 0 to 24, and this one to be 0 to 60, and this one also to be 0 to 60. How can we ensure it here? Well, there can be two possibilities at least, at minimum. One could be you define your own validate method within this class. So this validate will tell you, and then you use that validate method here in your constructor over here. Now, if some other component doesn't agree with the values you provide, then they can't proceed. Now they will have an error. You will validate and you will reject. Maybe you should raise an exception or something. That can be one possibility. Or another possibility could be, as I said earlier, you may decide to have enumerations or classes. So what is hour? You just define 24 values. I mean 20. So midnight, 1 a.m., 2 a.m., 11 p.m., so on. And a minute, 0 to 60, right? 0 to 59. A bit more values, but still doable. Same thing for second. And now once you do that, now there is no way to make such way. So now your code is actually enforcing based on connaissance of values. And then we have connaissance of identity. Occurs when multiple components must reference the same entity. Okay. So one common example could be when independent components need to access and modify a shared data structure, such as some kind of distributed queue. I can give you an example, like let's say you got a global counter in your website. And whenever someone loads your page, what you want to do, you want to add that there is one more visitor. So you have some global counter and you want to not create that counter every time someone visits your website starting from 0. You want to add 1 to the existing counter. So you got some kind of distributed data structure, maybe int variable, maybe a queue, some kind of thing, and you want to update that value. You want to keep that. So that is that is the connaissance of identity. So here is this example. How we can do that? Like here, like in your controller, you have this global counter. And then whenever someone visits your page, you just want to increment your counter, saying that whatever the previous value was, now it is +1. So another visitor visits, another visitor visits. How can you do that? One way of, okay, so how many of you already know what singleton pattern is? Do you know what single pattern? Yes. So some of you are saying that yes, we know. Yeah. So you may have studied it with Bennett in the course about design pattern course or advanced object oriented course where you discuss these design patterns. So we can use that in order to enforce connaissance of identity. So here I will motivate my example in the next slide here. So let's go through it slowly. So this is my singleton pattern, a global counter. What it has is it has a static global counter instance. And then it has a count variable starting with 0. The first thing I must do is, so that no one can create a new global counter, would be to make my constructor private. Now, no one can create an instance of this class. It's a private constructor. No one can say global counter equal to some name equal to new global counter. Why? Because whoever will say that out of this class, they can't see this constructor because it is private. You can only create a new instance of global counter within that class, within from here to here. So this is through this method, you will provide a global access to the same uh, variable you created. So you are going to the same identity you just once created. So it's a static, synchronized global counter get instance. This will give you the instance. This will give you the instance of this class. And here you check this. If instance is null, that means instance doesn't exist before. It is the first time someone is visiting your website. First time ever. Then only you create a new global counter with count equal to 0. And this is the only time you will run this piece of code because instance is null. Otherwise, what you will do, you will just return your existing instance that you have it here. So in previously, it would have been created, and now that instance will have some same state. Whatever the count is, you will receive that. And you have this increment method, just plus plus in your count, and you can also return, current count because these are private. If you want to return count, you just get that through this method, this public method. Okay, so let's use that. So in your application, all you do is you have this global counter C, and here, since it's a static method here, you say global counter dot get instance. So you call this one. I should have put these two brackets here. Sorry for that. Dot current count. And here I just get the current counts. So I now receive the instance, get the current count, and put it. I should not have, by the way, this is global counter. I should not have done that. Sorry for that. Just right here. Get instance. It gives me the existing counter. And if there is no existing counter, it would create through this and give me back. And I will have it here. All I need to do is, so action result home, whenever someone comes to our website, I make an increment to it, calling this method. So it's a global counter. So through this kind of mechanism, you can enforce the connaissance of identity. So we covered all the connaissance. We started with name and now we just finished identity. So there are three connaissance properties you need to look at. So one is strength. You want to be, by the way, in this optimal area. You want to be in this area. Strength, strong to weak. Bring it here. Locality. Locality simply means how dispersed your code is. Try to, if refactor it, refactoring direction should be close. Bring it over here. And then degree, bring it back to low. So there are three things: strength, locality, and degree. Three dimensions of connaissance properties. Strength is all about the ease with which you can refactor your code. So the strength on connaissance provides a good refactoring guide. So if you try to be above, then it would be easier for you to refactor your code. Okay, so should prefer static connaissance to dynamic because developers can determine looking but simple source code analysis that what are the dependencies in your code, and you can go there and make changes. Locality, proximity of code within your code base. How close those code modules are from each other. If they are pretty dispersed, try to bring them close in the hierarchy of your code. And finally, degree. So the degree of connaissance relates to the size of its impact. So lesser degree of connaissance. So what degree really means? The impact, like does it impact a few classes or many? So whenever you have to make some change in one module, ask yourself how big or small, to what degree the effect will be if I make this change. So that is what degree means here. So lesser degree of connaissance damages code base less because the effect is a bit smaller. You can control it. If you have high, so having high dynamic connaissance isn't terrible. So like for instance, you have dynamic connaissance in your code, but your code base is really small. The impact of changes is really small. You can just count those, go to those places and fix those refactoring. So if the size of or the degree, the effect degree is more like an effect. If the effect is really small, then it's all right sometimes just to be in this dynamic connaissance. So three things actually affect your maintainability of code. As we said, it is strength, locality, and degree. So I'm just trying to say the same things in this slide again. So three guides for using connaissance to improve system modularity, minimize overall connaissance in the system. Like for instance, if you have a pizza order system, try to separate your code into at least two distinct modules. One is about order processing, another one is about pizza ingredients and making. So don't try to put everything in one place. Try to make two modules at least. Minimize any remaining connaissance that crosses encapsulation boundaries. Minimize the connaissance within encapsulation boundaries. And of course, control the rule of degree, convert strong forms of connaissance into weaker forms. That is coming from dynamic to static. And rule of locality, try to bring similar modules closer to each other within your code base. And these are some frameworks and tools that can help you analyze your code bases. So like SonarQube, it provides support for Java, Python, C Sharp, JavaScript, Structure 101 for Java, C, C++, C Sharp. There are and depend for C Sharp, .NET, ASP.NET. JArchitect is for Java, ArcUnit for Java, and so on and so forth. You can depend on these and you can use those to check how modular your code is. And we studied a lot of metrics today and in previous lesson. All those you will find them implemented in these tools. So once now you are using them, you will know what it really means when I use a certain metric. So that was our this lecture, part of this lecture. So let's take a 10-minute break and then we will start our next part of the lecture. Okay, we will come back at, let's say, 2 minutes past 11. In the meantime, okay, so welcome back. Now we will start looking at non-functional requirements or quality attributes or architecture characteristics. So your course book calls them architectural characteristics, but other names that you will find in literature are quality attributes or non-functional requirements. And the slides I'm going to go through today is about chapter 4. Can you hear me? Just want to make sure if everything is working.
Yeah.
Great, great. So quality attributes, these are known as non-functional requirements, architectural characteristics, and things like availability, performance, security, requirements, data, legality, scalability, etc., etc. So requirements gathering is an initial step when a company decides to solve a problem using software. And you have seen that, like from the very first semester when you were enrolled in this program with courses like and scavening of IT system, you worked on requirement gathering, and then you started working on some UML diagrams, how those requirements can be translated into design. Of course, that is a starting point for um, a company, for a software development. You work on requirements gathering. And requirements can be categorized into functional requirements, how your system will work. It's all about the main functionality of the system, but also it should, we haven't talked about much about these things, but uh, it should have some quality attribute requirements, like your system should be so what they do, your system should be available, your system should be have accessibility things, so that it is workable for large audiences, especially for with persons with disabilities, etc., and so on. So what these quality attributes do, they kind of annotate or um, um, qualify your functional requirements. They kind of adds up to the functional requirements of your system. So availability, modifiability, usability, security. Like imagine your system is working the way it should be, but there is no security to that system. How good that system would be. Or imagine all the functional requirements are fulfilled by your, within your system, but your system is not available. Every time, you try to host it, something happens and availability becomes affected. So how good that will be. Or usability, it has some bad usability features, and it is really hard to use that software. So quality attributes are equally good as functional requirements. We call them non-functional requirements. And it is about the architectural considerations. What architects usually do, they go beyond the domain functionality, and they analyze for the non-functional requirements or architectural characteristics, how secure that system will be, how easy it will be to modify, because in future requirements will change, how we will make it available most of the time, how usable it will be, and so on and so forth. And these are also really important, factor, independent of problem domain. Doesn't matter what problem are you solving. Is it a pizza delivery system? Is it Uber kind of software system you develop? Is it a hotel management system? All these require some quality attributes like security, usability, modifiability, availability, and some others maybe. So we can say that if you have functionality on x-axis, there must be quality on y-axis, and then only we can see how good or bad your system is. So let's say your system in functionality is, let's say, really good. So, okay, so this means the system in functionality is really good, but it doesn't support much of the quality attributes. Then it's no good. And if you end up here, like it is available all the time, it is very secure, usable, but the things it's supposed to do, it doesn't do those things. So you will probably end up here, not good either, because it is available, modifiable, usable, secure, but the things it should do, it does maybe very little of those. So it is best to be somewhere here, where you have reasonable of function, confidence in the functionalities it provides, and it has reasonable way of doing, providing quality attributes, or not quality, non-functional requirements of your system. So both are important. So your role as an architect would be, in a first step, before you start drawing diagrams, would be to think about what architectural characteristics your software should support. So the non-functional requirement should be the first thing you should think about. And architectural characteristics specify things like, the operational things of your system and the design criteria for success. How how would you say that your software is successful? What will make that? Making it secure, would that count in? Making it available, would that count in? So you have to ask these questions like this. So the course book says that your design is supported by three things. The design of your software will be supported by three things. And if any one of those are absent, your design is not good enough. The first thing is you have to specify a non-domain design consideration. Second thing says your design is also, you should have, things like the structural aspects of your design. So you have to consider them. And finally, you have to have architectural characteristics or quality attributes. And these will be critical to the success of your software design. So three things above on these three things, your design is standing. You make one of them weak, then your design will start to get weakened. So let's go through them one by one. So the first thing is this specifies a non-domain design consideration. So it's more like operational things. It's non-domain design consideration. Non-domain means it's not really related to the problem you are solving. Maybe you have a bank application. Maybe you have a pizza delivery. Maybe you have Uber or something. So these are non-domain design considerations because you need, reliability. You need things. So you will consider those operational things like you. And by the way, these operational things, usually you don't find them into requirement document. Requirement document will say about, okay, we need to have an address book and I should be able to schedule something, this and that. But it will probably not say that that application should be available all the time because we consider that, of course, it would be there. How the performance could be that, maintainability could be that, like preventing technical debt. Technical debt, what is technical debt? Technical debt is, in our life also, when you are working in a software industry, company, there are so many things you need to work on. There are so many new features you are working on. And with the passage of time, there is a backlog you start to have, and then we start to make, a priority. Okay, this feature has more priority, let's do this one now, and let's leave the other things for some other time. And that makes it some kind of technical debt. Things, starts to disorient, go away from the ideal structure we once envisioned for our software. So it's about the maintainability. Your code starts to smell means, your code starts to like a bad food, it starts to rot a little bit. So that all is also called something, like technical debt. So this is the first thing you need to look at. And then the second thing is uh, your design is also influenced by some structural aspect of the design. So, for instance, it requires special structural considerations to be for a success. For instance, security consideration within a payment system. And now you have to ask, is this thing that I am working on, like maybe security, should it be done by me within this project as an architect? Should I develop a component in-house, or should I outsource it to a third party payment processor? So that is a some kind of structural aspect of your design. So how you can go for it? Let's have a discussion. I will ask your opinion here. So what you can do is when you are designing or architecting a system, you can, give it to a third party. You just buy a third party payment processor like, a Swish or something, embed it in your system, existing application, so that people can make payments through that, or you develop something in-house. And I want to ask you, I will give you some scenarios and I want your input, which one you will prefer. Let's say it's just a pizza related or food related application. What would you do? Any suggestions? As an architect, what you will go for?
Third-party payment.
Yes, I would also go for a third party payment. I mean, why would I? It's a pizza, right? I mean, uh, at the end of the day, third party payments are doing a lot of work. So we can do that, right? So this is the consideration you need to make. Instead of doing security of your system yourself, this payment processing could be done by a third party or security consideration. Let's now imagine a system owned by government. Okay, it's a highly I mean, it is something our national security depends on, that kind of system. Maybe controlling our nuclear reactors, maybe controlling some of the drones we have in our military, maybe controlling important stuff. Now, as an architect, what would you prefer? Would you like to give your security considerations away to a third party processor, or do it yourself within in-house within the software? How would you go now?
In-house.
Exactly. I would do the same in-house because the stakes are too high. We can't really depend on others, third party components in this situation, right? Because there are so many people who wants to infiltrate to our security, maybe to our software system at that point. So you see, this whether you want to implement something on design level just by relying on some third party or doing it yourself depends on uh, the situation or the things we are in. Nobody will say that, but these are implicit. Domain knowledge will help you understand those. And then comes critical or important to your application success. How critical it is for you to have that thing. So if it is really critical, maybe you want to support that. But if it is not really critical, maybe you don't want to support it. I will come back. I will say the same thing. Like if it is too critical, maybe we have security implemented ourselves in house. But if it is not too much of the problem, it's not a critical application, we can rely on third party. So that kind of thing. Why we do that? Because you have to choose fewest of quality attributes. We can't really support everything. We have to pick one or few, not one actually. We have to pick very few. Why? The more quality attributes you want to implement in your system, the harder your design will become. So you have to balance the complexity of the system by selecting only the most critical characteristics or quality attributes that you want to support. So then you can have, explicit and implicit architectural characteristics. We talked about them here, um, over here also. So let's see. So implicit characteristics are not discussed within the requirement documents, but you still need them: availability, reliability, security. And then explicit characteristics are actually discussed within the design documents or requirement documents you are given. So let's categorize some of the non-functional requirements or architectural characteristics or quality attributes. So you can have operational architectural characteristics like covering capabilities like performance, scalability, availability. So the most common ones we can think of that comes back again and again. It could be availability, it could be scalability, it could be performance, it could be recoverability. How easy it is for you to recover from a setback if your software is down. So these are operational characteristics. So it's more like, where you host your system, that it will be controlled by that. Then comes structural architectural characteristics. How did you structure your code or modules? So it could be like how easy it is to configure your code, configurability, how easy it is in terms of extensibility. If we support few features now, how easy it would be to integrate more features? Is it extensible? And I will give you an example of an extensible system. Like you all may have used Eclipse, for instance, for Java or for any other programming language. And in Eclipse, if you look at it on a bare bone, Eclipse is just a text editor. And then you start adding plugins. It is so extensible, you add a plugin related to C++ and Eclipse works for C++. And you add a plugin for Java, it starts working for Java. You add a plugin for J2EE and it starts working for that, and so on and so forth. So we can say Eclipse is really extensible. So do you want to have extensibility for your system? Maintainability. How easy it would be for you to maintain your software afterwards? Then cross-cutting architectural characteristics. Cross-cutting architectural characteristics are those we really cannot put it into structure or operational. It is somewhere in between. So in similar way, it is a fancy word, cross-cutting, for architectural characteristics that we don't know where to put them. So like accessibility, achievability, usability, these kind of things. And in your coursebook in chapter 4, this table is given to cover the most common operational architectural characteristics or quality attributes. The most important one is availability, for instance, because a lot of applications need that availability. How long the system will need to be available. So availability is that. Performance is really important. Includes stress testing, for instance, peak analysis, analysis of the frequency of functions used. So, for instance, performance acceptance sometimes require an exercise of its own, taking months to complete. So performance is really important. And for some critical systems, maybe recoverability, how easy it is for us to recover from a fault. Let's say it's a nuclear reactor operating, a software system we developed, and some sensors are not working. Some piece of software stop working. How easy it is for us to quickly to recover from it. So like business continuity requirements. It could be not, a nuclear reactor. It could be a banking application also, because we need to be available and we need to recover from the attacks that and especially in cyber security area, we know that a lot of attacks are done on our websites, on our applications. So let's say you have an account with a bank, you want to recover if something happened with your system. So recoverability. And then comes reliability. Reliability is really how reliable your system is, how fail safe it is, that kind of thing. How safe your system is to use, especially like we have, in hospitals, we have a lot of devices controlled by some software. Like if, God forbidden, if someone gets a cancer, they go to hospitals. Sometimes, they do these rays for, targeting those cancer cells. So those rays, the amount of rays, the targeted area, all that is controlled by the systems. And it has to be, those system needs to be safe. Safety should be an important part in those systems. Robustness, ability to handle errors and boundary condition. Scalability is really important. So for business applications, I would say scalability is really important. Availability is really important. Maybe performance is important. Recoverability is really important. So scalability is what scalability means. Over a passage of time, your users grow. Can your system scale to the needs of the users? So that is what scalability is. Ability of the system to perform and operate as the number of users or requests increases. So these are operational characteristics. Operational characteristics can be given to, or given to some cloud providers, for instance. So if you decided to run your software to AWS, for instance, or Microsoft Azure, then you can kind of give these availability and scalability problem to them. Though you program, you try to fix your infrastructure in a way that you provide these non-functional requirements, but it would be now the headache of that cloud. Structural architectural characteristics. This is what you will probably do within your system when you are designing it. Configurability, how easy or hard it is to configure your software. Ability for the end users to easily change aspects of software configurations through usable interfaces. Then extensibility, how easy or hard it is to plug new pieces of functionality in. And I gave you an example of Eclipse. They have done it really nicely. Eclipse is really an extensible piece of software. But of course, some other piece of software may not be extensible at all. Installability, how easy or hard it is to install all the necessary things within that piece of software. Leverageability or reuse within the system. So how good or bad your software system is to utilize common components across multiple products. That would be reusability or leverageability. Localization, how good or bad your software is to support multiple languages. European languages, English, Swedish, Danish, Japanese, Chinese. So it is about that, localization. Maintainability, how hard or easy it is to update, change, enhance your system. Portability, how hard or easy it is for your software system to run on multiple platforms. And like imagine now games, for instance. You develop a very nice game. It is so, it has been, perceived nicely, but it is for to play on a, Xbox, let's say. And now you want to port it on mobile. How hard that would be. And you want to port it now on desktop computers. How easy or hard that would be. So that is about portability. An example given here is like, does the front end need to run against Oracle as well as SAP if it is a business application? Supportability. What level of technical support is needed for that application to run properly? Because some systems are really difficult and hard. The business processes are hard. So for instance, if you have worked with some SAP product, those are not intuitive at all. Those accounting softwares, a lot of business softwares, especially related to banking, they are not intuitive at all. And you need support with the application to work properly, to understand how a business process will be achieved in those systems. So supportability, how good or bad you support. Upgradability, how easily or quickly your system can be upgraded to the newer versions. So these are the structural architectural characteristics. So when you are designing your software, you have to focus on these, whatever you decided to pick. And these are some cross-cutting architectural characteristics. Why we call them cross-cutting, as I said earlier, we don't know. We can't fit them here in structural architecture. We can't structural characteristics, and we can't put them into operational. So these are kind of mixed. Accessibility, access to all users, especially with people with disabilities related to hearing, uh, uh, different kind of losses, color blindedness, and so on. Archivability, how easy it is to take, backups, archives over time. Authentication and authorization. So a need for any software system in modern time. Authentication is to check who you are. Are you really who you are, you say you are? Here we can have, username and password and things like that. Two-factor authentication. And then authorization. Okay, we know who you are, but what rights you have within our system. That is authorization. Like as a faculty, what things I can see when I go to Canvas. And as a student, what things you can see as a student. So authorization. Legal. What legalized legislative constraints we have within our system related to maybe data protection, GDPR, and so on. So maybe the software you are designing, legal is important characteristic to consider, and maybe not. So you have to decide. Privacy. If it's a medical database system, maybe privacy is really important to have. Maybe you want to encrypt everything when you store it in the database. Maybe you want to encrypt and decrypt whenever some communication happens among different components over the net or within the system. Security, how secure your system should be. Supportability, how much technical support is needed. Again, accessibility, you have it here, and here we have usability, much related. Usability, how easy it is to use your system from the perspective of user interfaces and all that. So for instance, here it says the level of training is needed to, for users to use it. So if your system is more usable, it would be easier for users to use it easily. And if it is not usable, usability is low, then it would be really hard to use your software. And then, so these are the categorization your course book does. And then in ISO definitions, they categorize these quality attributes like this. So they say that their system should have some kind of functional suitability. And when in functional suitability, they talked about functional completeness, functional correctness, and functional appropriateness. So does your software provide all the functions it should support? Functional correctness, are the functionalities you provide actually done correctly according to the business processes? Functional appropriateness, the functionalities you provide, are they appropriate for the the requirements given to you? Then comes performance efficiency. So this is functional requirements. From here, more of them, from here onward, these are non-functional requirements or quality attributes. Time behavior, resource utilization, capacity. Compatibility, how compatible that software is in terms of interoperability, how easy it can communicate with different pieces of softwares. Coexistence, some compatibility, how compatible your software is with existing pieces of software, with software available, components available in market. Usability, we have discussed about it previously. It's more about, appropriateness, learnability, how easy it is to learn, operability, how easy it is to operate, and so on. User interface aesthetics, how good or bad user interface is. Accessibility also, they try to put it within usability. You see there, so you can see that there is no common here. We had defined usability separately from accessibility, but in this definitions they try to put them together in under one category. Reliability, and they try to put availability, fault tolerance, recoverability inside. Security, like integrity, authenticity, accountability, confidentiality, they put it everything in under security. Maintainability, how modular your system is, how testable your system is, how reusable your system is, and so on. Portability, how adaptable your system is. You develop that for Windows. Can it work for now easily on Linux-based operating system? You develop a game for Xbox. Can it work on mobile now? And so on. So the first thing we note is that these quality attributes are not properly very well defined. You can have different people, different books defining them differently. So you have to fix when you say usability what you mean. So you have to do that within your organization. And now we will talk about trade-offs and least worst architecture. So the more architectural characteristics you try to put in, the the more complex your design will be. Okay, so applications should only support few architectural characteristics so that you can support your design. You don't have, you have every company, every organization have limited resources. So you have to pick some architectural characteristics, not all, so that you can timely do the design. The design effort should be manageable. And this is called what is called trade-off. So you have to see, if I improve security, for instance, in our system, then it will definitely negatively impact our performance. Why? Because when you improve security, you try to add more on-fly encryptions, you try to add, proxies for secret hiding, you try to have more and more algorithms that would make your data secure. But since you are relying more and more computing things before it goes from place A to place B, you are impacting the performance of your system. So that is the trade-off. So you have to decide which trade-off you are comfortable with. You know that when you will add security, performance will be impacted. And know that when you want to have a lightweight, high performance, fast piece of software, then you can't really have much of security. That is the trade-off. And then comes iterative design, coming back to agile principles. We should, in the modern time we are living in, architects should strive for iterative architectural design, and it allows for easier changes and stresses less about the first attempts. You just try to build in something quickly to show it to your business stakeholders, and it also allows us to fail safely. We can always go back 1 week, 2 weeks, 1 month of effort and come up with another feature, come up with implementation of something else that may satisfy our architectural characteristics, may satisfy our stakeholders. So we have to employ agile principles because on all levels, so that our system, we do things quickly. We can adapt to the changes and see what is working and what is not working. And here there is this quote from your course book: never shoot for the best architecture, but rather the least worst architecture. So you should aim for the least worst architecture when you are designing, and design it in iterative way using agile principles. So that was our next lesson. So I would want to take your feedback. So how is it going so far? Anything you want to add up?
It's good.
Okay, so I will do a little bit, few more slides. Okay, so now we are going to cover chapter number 5 in the course book. And with this chapter 5, 6, and 7, you will be ready to solve your assignment number 1. So you can start early. And also I have put the time there. You can go there and book a time for your assignment one. So chapter 5 is about how do we identify our architectural characteristics for our software that we have to develop. We just learned about what architectural characteristics are in chapter 4. And chapter 5 is now defining what are the architectural characteristics. Could you please give me one moment? I would, just one moment, please. Let me see. So, yeah, so what we will do is we will go for just 15 more minutes and we will stop, okay? So, identifying architectural characteristics, how do we identify? So the first step is that, whenever we develop a piece of software, uh, uh, defining or selecting or identifying architectural characteristics is the first step we do. So architect needs to understand the domain problem, what problem we are solving, and they also need to collaborate with domain stakeholders to determine their domain concerns. What are the concerns they are having? And then there are three ways you can identify quality attributes from that knowledge. Sorry, just give me one moment. I'm so sorry. I have to take a call. I'm so sorry for that. So let's start from where I left. So identify quality attributes at least three ways. So we need to extract quality attributes from our domain concerns, like what are the area we are working in, and from those domain concerns we can pick. Um, yeah, it is working. Let me see. So we can pick quality attributes. And also we can pick it from the requirement documents that we receive. And then there could be some implicit domain knowledge that we have that can guide us to what architectural characteristics we should pick or identify. So like for instance, here are some common domain concerns and some common architectural characteristics suitable for those domain concerns. So we discussed three things. We discussed domain, here domain concerns, requirements, and implicit domain knowledge. We're going to look at them one by one. So architect must be able to translate the domain concerns to identify the right characteristics. And it is really important that we keep our list of architectural characteristics as small as possible. And here I would give you an example of, Vasa. How many of you know what is Vasa? Have you seen Vasa in Stockholm? The Vasa ship? You remember that?
Yes, yes.
Yeah. So, this is Vasa ship has been, discussed in your course book also. According the way, we should not pick architectural characteristics. Like you remember the story, right? The king wanted to have, as many characteristics to that ship as possible. So it was a warship, and at the same time, it was, like for instance, here at that time we had troop transport ships and we had gunships. The king wanted to be a ship that is two in one. Both things needed to be in that. And then there was usually such ships used to have one deck. The king wanted to have two. And because of that, what happened, it became so heavy because of these architectural additional non-quality attributes or additional architectural characteristics. It became so heavy that once they fired a gun from that ship, it got sink. It sank. So that is a classic example how we should not pick architectural characteristics. We need to pick architectural characteristics very carefully, wisely, and we try to limit ourselves. Like in your assignment one, I will ask you, once you have done the exercise, I will at the end, I will ask you to pick top 3 architectural characteristics that you want to support. You can do this exercise with your stakeholders also, asking them, okay, there are so many architectural characteristics, but what are your most top architectural characteristics you want to have in your software? And then you can start it from there. So then these are some domain concerns, like if your software is about mergers and acquisitions, like you will merge a lot of components sooner or later, then you should support interoperability, scalability, adaptability, extensibility. It should be extensible. Time to market, how quickly you want to bring your software to the market. If it is really quickly, then agility, testability, and deployability, how easily you can deploy your software, how easily you can test the additional things you add in, how agile your software is, how quickly you add in things to that piece of software. User satisfaction, if that is your domain concern, that your user must be really satisfied, then you may want to pick architectural characteristics like performance, availability, fault tolerance, testability, deployability, agility, security. I would go for, in that scenario, I would really prefer to have performance, availability. But of course, if it is a really critical system, we need to have fault tolerance and so on. Then comes competitive advantage. You want to, the domain concern is that this software will give you a competitive advantage over your competitors. Then you may want to have support agility because it's so agile, you can quickly launch it. You can quickly adapt it to new changes. And agility is also related to testability because how can you quickly launch it when you don't test it properly? So testability should be supported. And of course, deployability is also very much related. How, if it takes a lot of time to deploy your software, days, then probably agility is not kind of satisfied. So deployability, agility, testability are kind of similar to each other. Scalability, how your system react when a number of users increase. Availability, it has to be available. Fault tolerance, so these kind of, when you want to have some competitive advantage, you need to support these characteristics. And then time and budget, you are really concerned by time and budget, you need to have something simple so that you can quickly release. Feasibility, it should be feasible, it should be easily feasible with the resources you have. So these are the some common domain concerns and some common architectural characteristics that you can pick for those domain concerns. And I said agility does not equal time to market. For instance, here we have time to market somewhere. So if your system is agile, it may not uh, increase your time to market. It should be agility, testability, and deployability together that will shorten the time you need to bring your piece of software to market. So this is something you have to pay attention. Then comes the requirements. You got your requirement documents, and there in those requirement documents, some characteristics are explicitly mentioned. Like for instance, your stakeholders already know that they expect a number of users, and they expect that your software should scale. So that is something then you have to think about because it is mentioned directly in your requirements. So you have to pick those. There can be some implicit characteristics coming from inherent domain knowledge. So it's not written in the requirement, but through your knowledge of the domain, like banking sector, like a stock market, like auction system, like an e-commerce application, that can help you to think about some implicit characteristics also. Like here is an example. Imagine we are developing a software for class registration. Okay, class registration. And Just for, to make our examples really simple, assume we have 1,000 students and we need 10 hours of registration to complete all the registrations within our system. So 1,000 students need 10 hours of work to complete the class registration or course registration within our system. Now, here you need to ask yourself, should your system be designed for even distribution of registrations over time? Or based on human psychology, should you handle, should your system have the capacity to handle all these 10,000 students in the last 10 minutes? And what do you say? Anyone wants to contribute here? Should we think that everyone will register whenever, evenly within that time period? Or you think that most of them maybe will attempt to register for courses at the last moment in last 10 minutes?
Last 10 minutes.
Yeah, I would say the same, because stereotypically we try to procrastinate things, and we try to leave things before the deadlines, and then we hurriedly try to complete them. That this inherent domain knowledge of human psychology should let you decide, something like, instead of scalability, you also want to provide this, what is it called? Just go out from my mind. I will just, yeah, elasticity. So elasticity means, a certain bursts of users trying to access your application. So here the thing is, about these implicit knowledge, this comes from inherent knowledge, and rarely your design document will talk about these things. So you have to be vigilant to think about these elements like human psychology, how your system will be perceived and used. And finally, what we are going to do now is we are going to together look at a case study called silicon sandwiches. And what we will do, we will try to extract quality attributes from requirements in this exercise. So your course book call them, these such case studies, architectural kata. So kata is a Japanese word and coming from martial art. What you do is, when you are learning for different, in martial art styles, you spend time and you do some imaginary scenarios. You practice for some imaginary scenarios. So they call these case studies architecture katas, because what we are trying to do with these katas or scenarios is to simulate the real world scenarios and practicing on them. So this is what. So so these are simply just some case studies for our practice. So silicon sandwiches. The description is. Give me one moment, please. 1 second, please. Look at this case study yourself, and in the next class tomorrow, we can pick up right from here and go through this case study together. So for today, I think we can stop here. And tomorrow we will pick up from the case study right from here, and we will continue. In the meantime, you also go through that and we will pick up from there. So for today, I think it is good enough. We have covered pretty much, nicely the material. So I will stop here. If you have any questions, feel free to ask me. If no further questions, then I will stop the recording here and see you tomorrow then. Take care. Bye bye.
Goodbye.